electric field due to hollow sphere. Bad news is very worst derivation. Good news is we have a substitute for this derivation as a concept in future. So nothing much to worry. But if the derivation is understood decently also, that's fine. Even if it's not understood, is fine. But don't take it too seriously if you don't understand. Okay. Now, electric field due to a hollow sphere. So let us say this is my hollow sphere, and I want electric field at a distance of, let us say, r from the center. Okay. Let the radius of this hollow sphere be capital R. Okay.
Yes, sir.
As we know already that the element that we are going to take for a hollow sphere is going to be
D theta.
Yeah, d theta, which is, but geometry looks like a ring.
Variable radii varying.
Loop.
Yes, sir.
Ring. Right?
Yes.
So let at an angle theta, let us take a small element obtaining an angle d theta at the center, and the geometry of it is basically going to look like a ring. Right? This is my element.
Yes, sir.
Similarly, it will look the same in the back. Behind also. I'm not drawing it right now. Okay.
Yes, sir.
So now let us make the geometry clear thoroughly. So let us say center is O, where we need to find the electric field is P. Let the center of my loop be A. Okay. And
Yes.
let the point over here be B. So how will my geometry look like over here? So I have O and B, and somewhere over here I have A, and my element is at basically B. Right?
Yes, sir.
And my this angle is basically theta, and let me take this angle as some alpha, because we are going to use that in our derivation.
Yes, sir.
Okay.
Yes, sir.
Now the electric field due to any part, now this is the important thing, the electric field due to any part of this loop is going to be away from the loop.
Yes, sir.
And if you realize, the angle alpha for every part of the loop is going to be the same. And the distance is also going to be the same for every part of the loop. Because we have done the loop thing, the distance from every part of the loop is going to be the same, and the angle also is going to be the same.
The radii also will be the same.
The radii is also going to be the same. Radii, basically, if you say in terms of r sine theta, right? If this is r, the radii of the loop will be r sine theta.
Yes, sir.
Okay. The distance, I think what you mean is the distance from the loop to the point is also same for every point on the loop.
Yes, sir.
Right? So let us say that distance, basically let us say this distance BZ.
Yes, sir.
That means BP is basically Z.
Yes, sir.
And OP is basically small r. That is where we need to find the electric field due to the hollow sphere. Right?
Yes, sir.
Now, if due to every element If due to each element, if I say it is DE in this direction, away from the element, right, in that direction,
We need to take components because it will be
I need
very
to take component,
less. Yes,
right?
sir.
And that component sin alpha will cancel,
Mm.
and only cos alpha will be there, right?
Yes, sir.
Because this angle is alpha, my that angle is going to be alpha. So cos alpha component is going to add it. So can I write it as DE cos alpha?
Yes, sir.
And DE due to every element is going to have the same magnitude.
The integration.
So my starting point where I need to have a bit of understanding is that I can write the electric field due to the loop in the horizontal direction as DE cos alpha.
Yes, sir.
Understanding the fact that sine alpha due to the loop is going to cancel each other, its own components,
Yes, sir.
right? Fine?
Sir, but it will cancel if you take an symmetric element or
Correct. If I
somebody
take
like
the
that.
sine alpha component, automatically the diametrically opposite elements are going to cancel each other. So I don't have to be worried about it. Is it clear?
Sir, but without taking the second, uh, I mean, if you're not taking any other point in the sphere, then how are we telling the sine theta is getting cancelled if that point exists? Then only we can cancel it, right?
Correct.
So we have to take that one also.
Yes. I have to take diametrically opposite point on the loop
Yes, sir.
and it will cancel. What will
Yes,
cancel?
sir.
The sine alpha component will cancel.
Yes, sir.
The cos alpha component will add,
Yes, sir.
right?
It should become 2D cost.
So, for your understanding, first I will write that.
Yes, sir.
Okay, what I am trying to present over here, for understanding, I will write over here. Okay,
Yes, sir.
my d due to the entire loop is equal to the dE due to each element, or let's say point element, correct?
Yes, sir.
Cos alpha and integral of it due to each point on the loop and the cos alpha component of it. If I integrate, I will get the electric field due to the loop.
Yes, sir.
Now this d fellow, if due to each point, if I write, I will get, this is the exact same thing that we've done in our loop derivation also. So I'll have k, the dq due to a point element, right?
Yes, sir.
Divided by the distance is same for every point on the loop.
R.
Here it is z. In this figure, every point on the loop
Okay.
is
Yes,
at a
sir.
distance of z from the point.
Yes, sir.
So k dq of each point divided by z square into cos alpha.
Yes, sir.
So ultimately this will come out to be for me, if I integrate also, or even let me not integrate it first. Let me bring the constants out, right? For every point on the loop, k cos alpha and z square is same. Simply I have integral of dq of point, right? Each point.
Yes, sir.
And if you remember 0 to q by 2 limits,
Mm.
because diametrically opposite are cancelling each other.
Then there should be 2 out because
Then
we
there will be
took
2
the
out into q by 2. Eventually it will become q.
Yes, sir.
We should have 2 into 0 to q by 2, right? Eventually,
No,
I
I
can.
was telling that there should be 2 d cos theta.
Correct. But you understood that the sine theta is going to cancel each other. Eventually, when I integrate, I will get q only, right?
Oh. Sir, so you're taking everything at once. I understood.
Okay.
Yes, sir. Yes, sir.
This is one of the properties of our definite integral chapter of mathematics. In definite integration chapter, you will have properties of it, some 12 or something. One of the property is this, which also has a meaning, which I will discuss sometime later. Eventually, my final answer will be what? My final answer will be this k cos alpha by z square is same for everyone. It is going to be the dq of this ring, right?
Yes, sir.
That capital Q, whatever is there, is the dq of the ring.
Yes, sir.
Is this?
Yes, sir.
Now, here we are talking of uniform and we are talking of hollow sphere. That means my sigma comes into play and uniform means my sigma is a constant.
Yes, sir.
Therefore, my sigma, I can write it as, now I am coming to the hollow sphere as a single thing. As soon as I say sigma, that means I am talking of hollow sphere.
Yes, sir.
So, let the total charge on this hollow sphere be capital Q. Then my sigma can be written as total charge divided by the total surface area of the hollow sphere, right? 4 pi r
Yes, sir.
square. Or I can write it as the dq of the ring, the dq on the ring, right? The charge distributed along this ring divided by the area of the ring, dA.
Yes, sir.
What is dA for me in this situation? dA is equal to, I will run along the perimeter of the loop with a paint brush of thickness,
dr.
uh, let us call
dx.
it as something else, dl or something.
Yes, sir.
Let us call this along the sphere the width of it as dl, right?
Yes, sir.
And I am running along which perimeter? I am running along the perimeter of the loop.
Yes, sir.
Perimeter of the loop will be 2 pi radius of the loop, right?
Yes, sir.
That radius of the loop is r sine theta.
Yes, sir.
Is this clear?
Yes, sir.
So my dA will be 2 pi r sine theta. So this 2 pi r sine theta is me running along the perimeter of the loop
Yes, sir.
times the width of the loop is dl. In our case, we have taken it as dl.
Yes, sir.
But what is dl? I'll draw a small figure for that. So this is my d theta subtending, right?
Yes, sir.
And this is my dl and this is radius. So dl is nothing but r d theta.
R dt.
So I'll just substitute that over here. So what will I get here? 2 pi r square sine theta d theta. This is my dA. Is this?
Yes, sir.
So the dA story I'll substitute here, cross multiply, I'll get dq of the ring.
Yes, sir.
So now coming back to my loop. Okay. First we have tried to understand what will be the loop story, right? By taking a
Yes, sir.
point on the loop. After that we are starting from loop to the Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. So the dE due to the loop is equal to K dq due to the loop, right? Loop or ring, whatever. Okay. Into cos alpha divided by z square. Is this clear?
Yes.
So let me further substitute what is dq due to the ring. So k divided by z square. What is dq? Tell me. Sigma times dA.
Yes, sir.
What is dA?
2 pi r square sine theta.
Is this clear?
Yes, sir.
2 pi r square sine theta d theta. So my dq is done.
Yes, sir.
Outside I have cos alpha and everything is taken care of.
Yes, sir.
Just to write it in a refreshed manner, I will take my constant stories outside. So my constants are 2 pi k, correct?
Sigma.
And my sigma is what? Capital Q by 4 pi r square. Okay?
And we can take out r square.
We can take out r square also, which will cancel. Sigma is taken care of. 2 pi r square is taken care
By
of.
z
K
square.
into z square. Yeah. So here I have sine theta d theta is one story. I have cos alpha is
Even
another.
now z square is also a constant, so why can't we bring it?
Z is not a constant for sphere. For a loop, Z is constant. But along the sphere, if I am running, Z is varying.
Yes, sir.
Is this clear?
Yes, sir.
So eventually I landed up to this situation. So till here is fine, right?
Yes, sir.
Okay. Now we have to understand what this thing is. Okay.
Yes, sir.
So first let me take care of this sine theta d theta.
Yes, sir.
So I have small r, which is OP, right?
Yes, sir.
I have capital R, which is OB, and I
Yes,
have
sir.
Z, which is BP.
Yes, sir.
And the angle between OB and OP is theta.
Yes, sir.
Here I want to mention one statement which I mentioned some time ago, 3-4 days or 5 days ago. In physics, it is always, before doing any substitution or anything, it is always preferable to first look at the geometry and take help from it. Most of the derivations we do that way.
Yes, sir.
So here I have two variables. One variable is theta and the other variable is z.
Yes, sir.
And I have both the variables in my story.
Yes, sir.
Integration, at least till whatever we have learned, we prefer to bring everything in terms of one variable. either z
Yes,
or
sir.
theta, right?
Yes, sir.
So let me understand how to solve this problem using geometry. So whenever I am doing a derivation and I am stuck in physics, especially mathematics, also it applies actually, but especially in physics for sure. Whenever I am doing a derivation and I am stuck, I will first think that I need to take help of geometry. Somewhere I am losing my school geometry thing, and that's how I will start thinking. Okay.
Yes, sir.
So simply, if I want sine theta d theta, and I already know the story that whenever I substitute, I will differentiate. So have to tend myself towards cos theta, because if I differentiate cos theta, I'll get sine theta d theta.
Yes, sir.
And in my geometry, in trigonometry, probably in mathematics, we already know the cosine rule.
Mm.
So using that, basically, I will have z square is equal to r square plus r square minus 2rr cos theta.
Okay.
Is this correct?
Yes, sir.
Capital R is a constant. Small r is a constant. Capital R is also a constant. Right?
Yes, sir.
And I've already made a substitution of z in terms of theta. All I have to do is differentiate. Whenever I substitute, I'll differentiate. So after differentiation, I will get 2z dz is equal to, these are all constant,
Yes, sir.
minus 2r capital R. Cos theta differential is also minus, right?
Yes, sir.
Sin theta d theta. Is this clear?
Yes, sir.
So 2 if we will cancel, I will have z dz is equal to r capital R sin theta d theta. Fine.
Yes, sir.
So from this story, if I want sin theta d theta by z square, sin theta d theta by z square, so I'll write like this: sin theta d theta by z square I am interested in. I will get
Yes, sir.
dz by r capital R z.
Yes, sir.
Why? One z I will take from here, and other
Mm.
z I will multiply and divide on both sides.
Yes, sir.
Is it clear?
Yes, sir.
One story is taken care of. Sin theta d theta by z square is basically dz by blah blah blah. Okay.
Yes, sir.
Next is cos alpha. Again, in the same triangle, if I use my cosine, right, rule,
Yes, sir.
tell me what will I get cos alpha as?
In the smaller triangle,
No, in the same bigger triangle.
there r square plus z square minus a square upon 2
Minus capital
r
R
z
square upon 2r.
minus 2 r z.
Fine.
Yes, sir.
So here only let me, because anyways we are multiplying these two, we need to multiply these, right?
Yes, sir.
I just have to multiply these two. So my sin theta d theta by z square into cos alpha is equal to, on the right hand side I will have dz by small r capital R z, right?
Then what did you take the distance of OP? Okay, yes, sir.
OP is smaller. OP is
Yes, sir.
smaller. Okay.
Yes, sir.
Cos alpha, what will I substitute? R square plus z square minus, or let me write it in a different way. I can write r square minus capital, they are constants.
Mm.
So I can write r square minus capital R square as one thing, and then I can write z square as another thing, whole divided by 2 small r into z. Okay,
Yes, sir.
fine.
Yes, sir. Yes, sir.
All I have to do is dump this fellow over here.
Yes, sir.
And let me see where I'll go from there. So my dE of loop can be written as, or I will write it as final E net due to the hollow sphere is equal to integral of dE of each loop, correct?
Yes, sir.
Is equal to integral of this story. Okay?
Yes, sir.
See, one thing, 2 pi r square, 4 pi r square cancel. I'll get 2 in the denominator.
Yes, sir.
Okay? So what all are there? K capital Q by 2. Fine?
Yes, sir.
K capital Q divided by 2. So that entire thing I'll have to bring here. Okay?
Yes, sir.
R square minus R square plus Z square divided by.
2R, sir.
Let me write it in a different way. I have Z square in the denominator. Okay?
And take common. Yes, sir.
Z square I have in denominator. That is one part. And apart from that, I have 2 small r square into capital R in the denominator.
Yes, sir.
And I am done. 1 by 2 small r square into capital R.
Yes, sir.
Just check if here. Okay. K capital Q. Remaining is only 2 in the denominator.
Mm.
Then this entire story. So in this story I am writing, I need to write dz. I have dz in the numerator, right?
Yes, sir.
So dz, I have small r square minus capital R square plus z square
Yes, sir.
divided by z square and divided by 2 small r square capital R.
Yes, sir.
Constant, 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 constant. I can take it out, right?
Yes, sir.
KQ divided by 4 small r square into capital R square. I can take it out.
Why did it become? Okay, okay, okay. Yes, sir.
Integral of. The reason why I wrote it like this is now I can write it as 1 plus small r square minus capital R square divided by z square dz.
Yes, sir.
Is this clear? Clear till here?
Sir, that bracket part.
This bracket,
No,
I,
that is fine.
okay,
Below one.
which below
1 plus R square minus Z square.
exactly this bracket I have written it like this. Z square by
Okay,
z
okay.
square is 1. Small
Yes,
r
sir.
square minus capital R square divided by z square.
Yes,
I have
sir.
written it separately. Okay,
Yes, sir. Yes, sir.
this clear? Xerox. We aren't
Right.
done. We aren't done with the integration, but I brought it to a form which eventually will make it easier in the future. From here, it becomes
Yes, sir.
easier. The problem is first the loop itself, dE due to the loop in the horizontal direction is dE due to each point charge cos alpha and integration of it.
Yes, sir.
First important story is coming to this story itself. Okay? That's why we have written that entire.
Here I have one doubt. I mean, this cos alpha is there. We can write it another way also. How do you know? You have to write in this way only. Like, we can write it as z square minus small r square plus r square. Sorry, z square plus r square minus capital R square by 2zr. Like, we can write three forms of it. How do you know? We have to write this form.
No, z square plus r square minus capital R square divided by 2
We
r.
can write it as z square plus capital R square minus small r square divided by
That becomes that
2zr.
angle. That becomes this
No,
angle.
sir, for us, in the properties of triangles, they told you can do like that.
I'll tell you what it is written in properties of triangles is cos A is equal to c square plus b square minus a square by 2bc.
Yes, sir.
Cos B is equal to a square plus c square minus b square by 2ac. And cos C is equal to a square plus b
Oh,
square
yes,
minus
sir. Yes, sir.
2ab.
Yes, sir. Yes, sir.
Okay, fine.
Yes, sir.
So the dA due to the first important point in this derivation, which I feel is important, is writing this first step that the dA due to the loop will only have its horizontal component, the vertical components of the loop by themselves of each element will cancel each other.
Yes, sir.
The vertical sine alpha components due to each point charges on the loop will cancel each other. So as a loop only, this again requires a little bit of imagination. This entire loop will have its own cos alpha component, no sine alpha story.
Yes, sir.
And what is this electric field due to the loop? Magnitude is the same due to the loop. So I will write k dq of loop divided by z square.
Yes, sir.
Is the magnitude. This
Yes, sir.
dq of loop or ring is nothing but integral of dq of each point.
Yes, sir.
That is what we derived in the above situation, right? So first
Yes, sir.
point is coming here. Next point is sigma. Sigma is
Yes,
total
sir.
charge divided by total area, or dq charge which is present on the element divided by dA of the element.
Yes, sir.
Correct?
Yes, sir.
So let me mention that the element loop has a charge dq ring, and the area of this element, let it have dA.
Yes, sir.
So I can write sigma as dq ring by dA also. And we are doing
Yes,
uniform.
sir.
Yeah, we are doing uniform. Therefore, I can write this as whatever, so and so.
Mm.
Now, because uniform, I'll say sigma is constant. So dq ring, I'll substitute as sigma into dA. Now, everything else is basically substitution. So there will be no difficulty from here to here.
Yes, sir.
From here to here, there will be no difficulty. Now, over here, what second important thing that I have to remember is usually in physics, the substitutions are taken from figure itself. I should not try to imagine a mathematical substitution analytically. Rather, I should imagine it from a geometrical perspective.
Yes,
Because
sir.
usually in physics, we get that. And if I have that approach, what am I interested in? I am interested in some z, theta, and cos alpha. So first,
Yes, sir.
what is my z and theta story? Also in z and theta story, I told you if I want sine theta d theta, I am interested in cos theta. So my
Mm.
cosine rule will give me Z square is equal to R square plus R square minus 2RR cos theta, which eventually once substituted, differentiated, I'll get sin theta d theta. Great. But I want to get it in terms of sin theta d theta by Z square. In this form I want to get. Next thing is cos alpha. Directly cos alpha is telling you to get in the cosine rule from the given triangle. So cos alpha is this. The remaining part is again easy, just rearranging it, because I have decided to integrate it in terms of z, one physical variable.
Yes, sir.
Is it clear?
Yes, sir.
Xerox still here?
Sir, I wanted to ask, like, you could take a symmetric element from A towards downwards, so D will be towards the opposite side.
Symmetric element from
A in this figure.
A is the center of the loop or ring.
Yes, sir. If we take R sin, R sin theta down.
Okay. Over here.
From there to P.
From there to P. Yes.
You can consider it as symmetric thing, and
that is what we have done here, right?
yes, sir.
That is the loop derivation that we have done earlier. That's why I did not draw all those things in detail. When you're saying this point, take a diametrically opposite point, that means you're talking of point. The integral of dq of point is my dq of ring, is helping me satisfy all those problems. The integral of dq of each point on the ring is nothing but the total charge on the ring. This is satisfying all the issues regarding that.
Sir, it's because you're not considering the sine theta component one, but you're telling it's getting cancelled. To get cancelled, you have to take
a diametrically opposite component, due to which sine component will cancel, only cos component will be there.
If cos component is only there, then we take 2.
And that cos component will also be 2 dE cos alpha.
Yes, sir.
In which my integral of dq will be 0 to q by 2.
Yes, sir.
The 2 into q by 2 will be q.
Yes, sir.
And when we take two components, my sine alpha is not much important problem.
Yes, sir.
So why should I consider sine alpha in the first place? Because anyways it is going to cancel. I am only interested in the cos component. And instead of writing it 2 dE cos alpha, I am writing it dE cos alpha. Limits of integration are 0 to q. Because eventually 2 into q by 2 or just q are the same.
Yes, sir.
2 will cancel and I will get my q. And that q is nothing but the charge on the ring.
Yes, sir.
So in this derivation of hollow sphere, my first step is telling dE loop is equal to k dq of the loop divided by z square and cos component. That means due to the loop only I am taking as a whole and automatically saying only cos component will be available due to the loop, sine component will cancel each other.
Yes, sir, I understand.
This imagination is also important, is what I was mentioning. I took a loop. Okay?
Yes, sir.
I took a loop. Electric field I know is in this way due to the loop itself. I am calling the entire thing is D. I am calling this entire cone that will form due to the loop. There is a cone that will form.
Yes, sir.
That entire cone only I am calling it as DE loop.
Yes, sir.
And in that I am saying due to this loop, whatever I am getting DE, only cos alpha will exist, sine alpha will automatically cancel. Everything I am doing in my imagination.
Yes, sir.
So actually,
Yes.
the first step for my hollow sphere is this. But DQ ring cos alpha story, to simplify, I wrote this entire thing.
Yes, sir.
And I want to discuss with you about sin alpha, cos alpha separately in a mathematical sense. Here, what I said was, anyways, my sin alpha will cancel, therefore, I will take cos alpha. First point.
Yes, sir.
Second point, I said I want to keep my limits as 0 to q. Why? Because 2 into q by 2 or q is the same. Right?
Yes, sir.
So this I have said in a very imaginative way. But mathematically also I want to prove it to you.
Yes, sir.
So right now, for this derivation, take it till here. We have further derivation continuation. After we finish off this derivation, in a small way, I will explain to you what I want to discuss about this cos alpha sin alpha story. But did you understand the cone imagination?
Yes, sir.
That entire thing that fellow is saying, see, everything is equidistant.
Sir, it's like all sin thetas getting cancelled and cos theta plus cos theta going on.
All cos alpha are going to add each other.
Yes, sir.
Zero. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.